Assalamualaikum warahmatullahi wabarakatuh. We are from Group 6. Today, we will present the Remote Sensing and GIS assignment. We chose Remote Sensing and GIS Applications in Forestry as a title. Our group consists of 6 members, which are Nur Mirna Elisa, Wan Nur Syadatul Amirah, Zul Hazman, Ani Zahira, and Muhammad Syamsul Akmal. Now we are going to the next slide.
Introduction. Remote sensing and GIS are considered as art and science of obtaining information about an object or feature without physically coming in contact with that object or feature. This method can improve monitoring, mapping, and management of forest resource. Originally, forest management inventories were primarily used for timber management and focus on capturing area and volume by species. In the past decade, forest management responsibilities have expanded. As a result, inventory data requirements have broadened to include measures of non-harvest related characteristics such as forest structure, wildlife habitat, biodiversity, and forest water ecosystem. The use of remote sensing by forest managers has steadily increased and promoted in large part by better integration of imagery with GIS technology and databases, as well as implementations of the technology that better suit the information needs of forest managers. Most importantly, the forest information obtained from remotely sensed data can be classified, such as detailed forest inventory data, broad area monitoring, and forest health and natural disturbance. Assessment of forest structure in support of sustainable forest management. However, even with this advanced technology of remote sensing, there are few difficulties encountered by humans when monitoring the Earth. In this discussion, we will find the difficulties that have been encountered by humans and propose a few ways to alleviate those issues.
Next, we go to the topic that will be highlighted, which is subtopic 1, difficulties or issues. We take remote sensing for example. There are more and more countries that have access to remote sensing capabilities. Although this technology is very effective in forestry, humans still face some difficulties when monitoring the Earth. The first potential problem is the statistical problem in forest inventories. This has also been a historical issue in the remote sensing industry. Forest inventories are carried out to provide an overview of the location, composition, and distribution of forest resources and their relative amounts in a particular area. Estimates may be affected and the total quantity of forest cannot be calculated. Therefore, analyzing accuracy statistically is very challenging. Next, the issue facing humans is difficulties in using remote sensing to measure forest degradation, even if the area remains a forest but with altered structure, composition, and function. This will complicate the work of identifying the affected areas. The amount of biomass lost over time in a particular area is difficult to estimate too. This in turn contributes to the complexity of mapping, monitoring, forest degradation calculations, and degradation concepts. Moreover, there are more issues like long-term monitoring of forest structure and function. Forest monitoring systems are primarily concerned with the forest area detection and area changes, but also monitor variables related to forest welfare. This indicates a large lack of knowledge and information about the diversity and distribution of species, as well as changes in the composition of species in tropical forests. A deeper understanding of the dynamic effects of forest resources such as climate, disturbance, and interactions is needed to determine the future of forests.
Next, subtopic 2, factor. These two discuss some factors affecting classification accuracy of a decision tree classified and also compare the performance of the decision tree with the of the maximum likelihood and neutral network classify. The second stage involves applying the decision tree, maximum likelihood and neutral network classify to insert coherent and intensity data and evaluating the utility of this type of data for land cover classification study. This study indicates that good classification performance depend on various parameters such as data type, scale of data, training sample size, and type of classification method employed. For statistical problem in forest inventory, it happens because forest inventory are carried out to provide an overview of the location, composition, and distribution of forest resource and their relative amount in a particular area. For long-term monitoring of forest structure and function, this is because this indicates a large lack of knowledge and information about the diversity and distribution of species, as well as change in the composition of species in tropical forests. Last, difficulties in using remote sensing to measure forest degradation. The impact of degradation varies from fine-scale structural change in canopy cover and height, or subtle disruption to ecosystem service to broad-scale loss of biomass. This change can occur over a range of partial and temporal scale. Different types of forests will respond differently to change, with variable coverage rate depending on the location and type, intensity and extent of degradation, such as a single monitoring strategy may not be appropriate for broad-scale application, rather a customized region-specific approach is required.
133,791 hectares as protected areas, which include water catchment forests, state park forests, wildlife protection forests, recreational forests, protection forests, and education forests in accordance with the provisions of Section 10, 1 of the Enactment Application National Forestry 1985. The next step is control deforestation. We must look to control it even if deforestation is completely inevitable. It is because young and immature trees should not be cut down as far as possible. We must look to avoid large-scale commercial deforestation as well. Adaptation practices such as clear cutting or selective cutting will be beneficial in the long run. However, illegal deforestation causes loss of revenue to the government and causes damage to the biodiversity and quality of permanent forest reserve areas. Remote sensing and radar services are fully utilized to control and monitor areas of permanent forest reserves that are at high risk of forest encroachment by local residents. In addition, protect against forest fires. Forest fires are the most common and deadly cause of forest loss. It can start due to natural causes or can be an accident caused by humans or even intentional in some cases. This is because when a fire spreads in the forest, it is very difficult to control. Precautions must be taken for such incidents, such as making fire passages, spreading chemicals to control fires, clearing leaves and dried trees. Meanwhile, afforestation is also one of the ways to overcome it, where we plant more trees in the area to increase forest cover by manual transplantation or planting fresh trees. It is an attempt to balance our ecosystem to reduce the effects of deforestation and environmental pollution of all kinds. In the meantime, other government agencies and various parties throughout the state need to launch the 100 million tree planting campaign. At the same time, it can increase cooperation with local residents, non-governmental organizations, and corporate bodies in conservation efforts so that the state government's commitment to these efforts can be realized.
Then lastly, let's move to our last slide, which is conclusion. Remote sensing and GIS have been a convenient technology, especially in application in forestry. But there are still problems and issues occur in handling such technology. problems when handling remote sensing is the statistical problem and obtaining accurate calculation and result. Long-term forest monitoring that requires more knowledge and understanding and difficulties to measure the forest degradation. The main factors that cause the problems are the performance of the remote sensing itself, the lack of knowledge and information for a long-term monitoring, and the variety of forest types that respond differently and difficult for single monitoring. There are a few ways to overcome, such as gazetting an area as protected areas of forest, to control deforestation and protect the forest against forest fires, afforestation, and launching the 100 billion tree planting campaign or similar campaign. Then, that is the end of our slide and presentation from our Group 6. Assalamualaikum warahmatullahi wabarakatuh. Thank you and have a nice day.